Hello, Fruitport High School chemistry students. We have another lesson coming for you today. And today I want to talk about how matter is organized and classified. And so today I want you to take some notes. I want you to draw what I draw. I'd like you to listen to my words and write down some vocabulary statements, and then use those for our homework assignment, which will be in Google Forms, a little survey for you to do there. So let me go ahead. I need a piece of paper, and let me talk about this here. All right. So our first thing is that we're still talking about matter and how matter is organized. Now, we took this definition already, but if you need to write it down again, write down matter is anything that has mass or takes up space. That's like a really formal definition. My definition is stuff. If things would be considered stuff, then we have different things. That would be considered matter, okay? Now, matter is broken down into two subcategories, and matter can either be a pure substance or a mixture, okay? So a pure substance would be any substance that is made of just one component. So if you had a sugar cube, that could be pure sugar. If you have water could be a pure substance. But if you were just to grab water out of a lake or a river, that would be a mixture because there's more than one thing within the water, okay? So a mixture, a definition of a mixture, write this down. This is a physical blending of two or more substances. So mixtures are physical in nature. And there's a reason we learned about physical and chemical properties and physical and chemical changes before this class here. Before this lesson, I should say. Now, mixtures can sometimes be separated back into pure substances, okay? So let's say you had a mixture and you wanted to separate it into a pure substance. To do this, we'll do physical methods. And our next lesson is really going to focus on the different physical methods to do this. And we do this by taking advantage of physical properties. If I had a mixture of a bunch of metals at a recycling plant and we needed to separate all the metals, some metals are magnetic and some are not. Some have a physical property of magnetic. So like recycling centers have giant magnets to separate out the metals that are magnetic or not as one of the steps to start separating all of the recycled metals into their individual pure substances. Sorry about the bell schedule there. All right. Now we're going to talk about mixtures a little bit and come back to this one. Mixtures are divided into two different types. You can have homogeneous mixtures or heterogeneous mixtures. Okay. And these prefixes are used in other terms we have in class, but homogeneous mixtures, write this definition. These are mixtures, physical blends that are so well mixed that their composition is uniform. So homogeneous mixtures are mixtures that are uniform in composition. Now, you might not know what those words means, but this is so well mixed that it's blended where the right looks the same as the left, the top looks the same as the bottom, the first sip tastes the same as the second sip. Heterogeneous have chunks in the mixture. This is one that are not uniform in composition. And so if you have things with different obvious zones that are not well mixed, this would be a heterogeneous mixture. Okay? Now you might know the symbol homo and the prefix homo and hetero from other places. Like in math class, you learn that homozygous was when you had two capital letters. That was homozygous dominant. Hey, they're the same. They're both capital. Or homozygous recessive. Hey, they're the same, but the lowercase. And heterozygous was when you had like one capital letter and one lowercase letter. Not the same. Also homosexual and heterosexual, right? Homosexual, they are attracted to the same gender that they are. Where heterogeneous would say that they're attracted to the opposite, right? Not the same gender that they are. So some words here. The big thing is coming up with some examples. So the best examples come from the kitchen. So I like to think of most heterogeneous things are like many soups and salads would be heterogeneous mixtures. You have a salad and it's mixed physically, lettuce and mushrooms and bacon and egg and cheese, but it's not the same. Every stab with the fork would not be the same. Where homogeneous solutions would be. I think most soups like chilies are heterogeneous, but an example of a homogeneous that would be uniform might be a tomato soup. Like that's pretty well blended, where every scoop might be the same. Homogeneous solutions are so important in this class that we have a word called solutions. So the word solution in the science class can mean like how to fix a problem, right? Answer to a question. But there's another word for solutions, and we have those. So if I dissolve a chemical in water and really mix it well, we'll call those like solutions. Okay, so. Anyways, we could talk more and more about these. Like coffee, I would argue, is a homogeneous solution. It's really well mixed. But orange juice, like really pulpy orange juice, would be heterogeneous because you're supposed to shake it up so all the pulp is mixed in and the nutrients and so on. So hopefully we've covered enough of the difference here. Okay. The last part of our lesson, our notes, is a pure substance. And a pure substance can be broken down into two answers. We have elements as one part and compounds. So elements are, write this definition down, elements are the simplest form of matter. They're like the basic building blocks of matter. And the elements are shown in a periodic table. You've seen on the wall. There's only like 100 or so, and most of those are not even that common, right? There's maybe 40 common elements we use in our world. And you can't exist in nature anything more pure or simpler than an element. Compounds are when you have elements chemically combined. So let's go ahead and write this down. Compounds are chemical combinations of elements. So definition, a compound is a chemical combination of an element. Remember, mixtures were physical blends. Chemical compounds are chemically combined. Okay. Now, you can, on rare cases, take compounds and change them into elements. That is not easy to do. And to do that, you're going to have to do a chemical change, okay? And we have that. All right, let's just do a couple examples so our notes look a little bit more complete here. So what if I said, another bell video. What if I gave you an example of river water? I think we've already discussed that. River water would be over here because not the left side of the river is identical to the right side. There might be a stick in one part, a floaty in another part, right? But if you had pure water, right, a pure water could be a compound, pure H2O. The H's and the O's are chemically fused together in a thing called a molecule for a compound, okay? What if I had, well, let's just do an element. Hydrogen would be an example of a pure element, or oxygen, right? Anything on the periodic table, iron or gold would be elements. Some other compounds could include like table salt or sugar, right? And some of the compounds have much more fancy sounding names like copper 2 nitrate, and we'll learn about all that stuff later in the fall. And then let's see, so homogeneous solution. Let me give you this one. Let me put the word blood, okay? Blood is definitely a mixture. There's a lot of things. If you study in biology, you'll learn blood is made of red blood cells and white blood cells and plasma and platelets. And it's all really well mixed, right? When you get blood drawn, it doesn't matter if they take it from the right arm or the left arm, right? Or the first drops of blood that come out at the doctor's office for testing, they're the same as the last blood. It's really, really well mixed together, unlike this. The textbook has some weird questions. They're like, what about a book? Which of these would be a book? And they're trying to do a heterogeneous, like, hey, some pages have more pictures, and some pages have less pictures, and so it's not always the same, and so they try to be creative with an example. But all right, so we got a definition of here for matter, a definition for mixture, definition of these heterogeneous and homogeneous mixtures, definition of compounds, and definition of elements. And we have a few examples, and I don't want to give too many examples because your homework assignment is going to be to analyze examples and see where it would fit on here. And we'll talk a lot more about this red arrow in our next lesson. Okay, cheers.